everyone, it's me, Jonette, your favorite 4-H agent. So today I have a lesson for you called Health Rocks. As you may know, or you may not know, but Health Rocks is a 4-H curriculum that is designed to teach you all about living a drug-free, healthy lifestyle. It is also a drug abuse prevention and awareness program. We're going to start today's lesson by talking about lungs. And to help me explain this lesson to you, I have a little helper. It is a slice of pig lung. I know what you're thinking. You're thinking this looks like a piece of bread. I know, but it's not. It's actually a real dried slice of pig lung. I know what else you're asking too. What are all those dark marks and holes that you see in this slice of lung? Well, those are your blood vessels, your capillaries, your arteries, and blood vessels. And there are other blood vessels that are really tiny in here that you cannot see. But why is this important? It's important for you to understand that your lungs are not hollow sacs that fill up with air whenever we breathe in. Your lungs are solid tissue, much like you see with this slice of lung here. Inside of that tissue embedded are tiny structures called alveoli. Those alveoli are attached to bronchial branches. Some people refer to them as bronchial trees. But there's a tiny network that extends all through this slice of lung. And at the very end are those alveoli. Those alveoli are teeny tiny air sacs. And when we breathe in, they swell up. And because of that, oxygen is able to infuse into these tiny blood vessels that surround those tiny alveoli air sacs. The oxygen comes into the blood, the carbon dioxide exits back into those alveoli sacs, and we breathe those out through our nose or our mouth. This is very important for you to understand, as alveoli are key components into our breathing.
Here's an illustration of some alveoli. As you can see in the picture, alveoli are also intertwined with a network of blood vessels represented in red and blue. These blood vessels bring blood from the rest of your body that is low in oxygen and high in carbon dioxide, which is a waste product of metabolism. The alveoli acts as a subway station where oxygen from the air that you breathe in is exchanged with the carbon dioxide in your blood. The carbon dioxide goes into the alveoli where it may be exhaled out through your nose and mouth. As oxygen gets off, it fuses with your blood and travels to the rest of your body to provide all of your cells with the oxygen that it needs. You can see how your lungs are so very important and helps to sustain our life force. When your alveoli don't work properly, your body can become starved of oxygen and unable to get rid of carbon dioxide. The National Institute of Health helps to identify illnesses that affect our lungs and bodies as a result of respiratory problems.
So now that you know a little bit more about how the alveoli work, let's see how breathing works. More specifically, how smoking and your breathing work, and why that is so dangerous for your alveoli and the health of your lungs. So here to help me is our skeletal smoker, who's going to be the victim of cigarette smoking. So here we have a cigarette. We're going to stick that into our skeletal smoker's mouth. Now, there is an apparatus behind my skeletal smoker friend here that allows him to breathe in and breathe out. So it's a hand pump. So I'm going to light Now keep your eyes here as our skeletal smoker blows out smoke and inhales. That smoke is going into their lungs,
clogging those alveoli with tar and chemicals. And while that's happening, I'm dying of secondhand smoke. Our smoker here is dying of first and secondhand smoke.
So now you should know why our skeletal smoker here is nothing but a skeleton. The skeletal smoker was breathing in the secondhand smoke and the firsthand smoke, which you saw. What you can't see is third-hand smoke. You may not have ever heard of third-hand smoke before, but everywhere where that smoke settles is going to leave residue. Residue of all the chemicals that are found in a cigarette. And that can sit for weeks, months, years on top of your ceiling, walls, on the tables, on the furniture, on your little brother or sister's chew toys. Any surface that is not cleaned daily and regularly will have these chemicals settled upon them. Now you're probably asking, what kind of chemicals are you talking about? Well, for so many chemicals, I need a piece of paper to tell me exactly what's in there. So, according to the American Lung Association, there are approximately 600 ingredients in cigarettes. When burned, they create more than 7,000 chemicals. 69 of those chemicals are known to cause cancer, and many others are poisonous. Many of those chemicals are also found in consumer products. And let me tell you what some of those other consumer products are. Acetone. You know what acetone is? That's your fingernail polish remover. Well, that ingredient is in cigarettes. Some others is acetic acid. And if you don't know what acetic acid is, ask your beautician, because that is an ingredient found in hair dye that would absolutely destroy our alveoli and our bronchial passageways, which is our air tube. Arsenic. Arsenic is poison. It's a rat poison. Benzene. That's something found in rubber cement. Carbon monoxide. That's the same kind of exhaust that comes out of our cars. And we know that that strips oxygen out of our blood and poisons all of our blood. Formaldehyde. That's embalming fluid for dead people. Lead, which is something found in batteries. Methanol, that's stuff they put in rocket fuel. Nicotine. Nicotine is one you've probably heard of. Nicotine is an insecticide. These are just a few of the ingredients that are found in cigarettes, in the cigarette itself and in the smoke that we breathe in, that the skeletal smoker here breathes in every time they smoke a cigarette. So can you imagine after years of smoking what that is going to build up in your lungs? This jar represents a whole year's worth of tar that builds up in your lungs when you smoke cigarettes. Now I know what you're thinking. How could something like that stay in our lungs? Because I showed you that your lungs are solid tissue. But it doesn't build up quite so much that it looks exactly like what you see here. But as you saw in the visual, your alveoli are sacs of air. When you get infection and mucus and pus that starts to fill up those air sacs, imagine instead of it being mucus and pus, but now it's tar. And now those alveoli are trying to open up and expand to breathe in the oxygen so that the carbon dioxide can leave your body. Only now it has so much tar and residue on it, they can't function properly. So now the oxygen can't get in and the carbon dioxide can't get out. You can come down with pneumonia, emphysema, and all other types of diseases whenever our alveoli are blocked and can't function properly.
Regardless as to whether or not you are the person who is vaping or smoking, or if you're in the room of someone who is vaping or smoking, you are at risk for suffering the same kind of lung damage. Electronic cigarettes, also known as e-cigarettes or vapes, may not contain tar like a regular tobacco cigarette, but they do contain large amounts of nicotine, pesticides, heavy metals, flavoring, and other chemical ingredients. These ingredients cause irritation and inflammation to your lungs and respiratory system, just like a regular tobacco cigarette. Along the way to your lungs, those irritants cause inflammation and irritation. The tar, nicotine, and other poisons leave a trail of destruction all the way to your lungs. Once inside your lungs, that tar collects in the alveoli and prevents oxygen from getting in and carbon dioxide from getting out. Healthy lungs allow an uninhibited exchange of oxygen and carbon dioxide in the alveoli in the lung. Tar from cigarette smoke sticks to the walls of the alveoli and begin to accumulate. Other harmful ingredients from vaping and cigarettes cause irritation and infection. Soon the tiny air sacs begin to fill with tar and mucus. The fluid buildup in the air sacs reduces the amount of oxygen that is able to make it into the bloodstream. This disruption results in an unhealthy buildup of carbon dioxide in the body. As smoking and vaping continues, breathing becomes difficult. Tar, pus, and mucus blocks the much-needed oxygen from entering the bloodstream. The person may suffer dizzy spells, blackouts, and unconsciousness. They also have an increased risk of developing other infections and illnesses due to the unhealthy state of their lungs and body. The National Institute of Health helps to identify illnesses that affect our lungs and bodies as a result of respiratory problems. These respiratory issues often cause blockages, called pulmonary embolisms, that prevent the flow of blood into the lungs. They also cause respiratory failure through diseases like COPD, ARDS, and pneumonia, which prevents the flow of air in and out of the lungs. All of these respiratory issues lead to death because without oxygen, the body dies. Tobacco cigarettes and electronic cigarettes, often called vapes, damage the only organ in our body responsible for making sure that oxygen gets into our bloodstream and carbon dioxide gets out.
The bottom line, vaping is not safe. And if you want to live a long, healthy life, then you have to make the choice and make the decision to not smoke cigarettes, to not vape. Breathing helps us to sustain life. We shouldn't do it.
You breathe in about 17,000 times per day. It's a process you rarely think about, but behind the scenes, a huge coordinated effort is playing out. Your vital organs, the gut, brain, bones, lungs, blood, and heart, work together to sustain your life by delivering oxygen to tissues throughout your body. Most of our cells need oxygen because it's one of the key ingredients of aerobic respiration. That's the process that produces a molecule called ATP, which our cells use to power their many incredible functions. But getting oxygen throughout our bodies is a surprisingly difficult task. Gas enters cells by diffusing in from their surroundings, and that only happens efficiently over tiny distances. So, for oxygen to reach the cells within our bodies, it needs a transportation network. This is where our 20 trillion red blood cells come in. Each one contains about 270 million oxygen-binding molecules of hemoglobin, which is what gives blood its scarlet hue. To make these cells, the body uses raw materials that become available from the food we eat. So in some ways, you could say that oxygen's journey through the body really begins in the gut. Here, in an amazing display of mechanical and chemical digestion, food gets broken down into its smallest elements, like iron, the building block of hemoglobin. Iron is carried through the cardiovascular system to the body's hematopoietic tissue. This tissue is the birthplace of red blood cells, and it can be found enclosed within our bone marrow cavities. The kidneys regulate our levels of red blood cells through the release of erythropoietin, a hormone which causes marrow to increase production. Our bodies churn out roughly 2.5 million red blood cells per second, a number equivalent to the entire population of Paris, so that oxygen that makes it to the lungs will have ample transportation. But before oxygen can even reach the lungs, the brain needs to get involved. The brainstem initiates breathing by sending a message through your nervous system. all the way to muscles of the diaphragm and ribs. This causes them to contract, thus increasing the space inside the ribcage, which allows the lungs to expand. That expansion drops your lungs' internal air pressure, making air rush in. It's tempting to think of our lungs as two big balloons, but they're actually a lot more complicated than that. Here's why. The red blood cells in the vessels within your lungs can only pick up oxygen molecules that are very close to them. If our lungs were shaped like balloons, air that was not in direct contact with the balloon's inner surface couldn't diffuse through. Luckily, our lungs' architecture ensures that very little oxygen is wasted. Their interior is divided into hundreds of millions of miniature balloon-like projections called alveoli that dramatically increase the contact area to somewhere around 100 square meters. The alveolar walls are made of extremely thin, flat cells that are surrounded by capillaries. Together, the alveolar wall and capillaries make a 2-cell thick membrane that brings blood and oxygen close enough for diffusion. These oxygen-enriched cells are then carried from the lungs through the cardiovascular network, a massive collection of blood vessels that reaches every cell in the body. If we laid this system out end to end in a straight line, the vessels would wrap around the Earth several times. Propelling red blood cells through this extensive network requires a pretty powerful pump, and that's where your heart comes in. The human heart pumps an average of about 100,000 times per day, and it's the powerhouse that ultimately gets oxygen where it needs to go, completing the body's team effort. Just think, this entire complex system is built around the delivery of tiny molecules of oxygen. If just one part malfunctioned, so would we. Breathe in. Your gut, brain, bones, lungs, blood, and heart are continuing their incredible act of coordination that keeps you alive. Breathe out.
Let's take a look at what happens inside of our bodies. One thing about smoking and doing things that affect the inside of our body, we can't see it. No matter how long you stand in front of the mirror, no matter how many selfies you take, you're not going to see the damage that you're doing to the inside of your body. Let's look at what's happening inside to our lungs when we smoke. So I have some other helpful tools to use. First, I have this wonderful apparatus that you see here, which we are going to use to properly display our lungs. That's right. So here we have a healthy set of pig lungs. Here we have a set of smoking pig lungs. What this wonderful apparatus does is going to allow us to inflate these lungs so that you can see how each one works. Okay? Don't worry, we'll give you some close-ups later. Here are healthy lungs. The first thing you're going to notice is the color difference in the lungs. Healthy lungs are going to be nice and red and pink. Now, smokers' lungs, when you smoke, all that tar, nicotine, and other things are going to contaminate your lungs. It is literally changing the tissue and the appearance of your lungs. Now, when you start experiencing problems with breathing, shortness of breath, then your doctor is going to want to know what your lungs look like. You can't see this standing in front of a mirror or taking a selfie. You can only see this through a process called a biopsy. And that's when your doctor goes in and pulls a small piece of tissue off that he can examine and send off to the lab for testing. Pink tissue versus black tissue tells a very telling story. Let's turn this off here and let's inflate our healthy lungs. So this is all hooked up to a nice airbag. So we're just gonna inflate. Don't worry, they won't explode. It's impossible for this particular setup. But what you see is how the expanse of the lungs occurs whenever we breathe. So remember what I told you before. Lungs are not hollow balloons. They are solid tissue. So those alveoli, those air sacs, when they breathe in, when they swell up to breathe in oxygen and that exchange happens, they really expand our lungs. Our lungs are not able to expand this greatly inside of our chest, and that's because of our rib cage. So these lungs can expand much larger outside in this apparatus than they can inside the body. So let's talk about what you see. Here is our trachea. This is the bottom part of the breathing tube that goes down your neck, okay? That runs through your throat. So we have a right lung and a left lung. Two pieces to our lungs. This is our bronchial tube that branches out into a right and a left bronchi that goes into our right and left lung. And remember what I told you about that tree? That tree has branches that go off all throughout the tissue of the lungs. So that way we are breathing in lots of good, clean air, oxygen, into our lungs that allows that to go and circulate in our blood throughout our entire body. So the blood vessels that are wrapped around those alveoli are now exchanging oxygen for carbon dioxide, so that way our cells in our bodies can properly function and heal themselves. Healthy lungs. So now let's take a look at the function of our smoking, unhealthy lungs. Again, notice the color, notice the sizes, notice the difference in the color of the tissue of the bronchial tubes, the bronchi, and our lungs. Now, you may be noticing there's a problem with the way these lungs are functioning. You may notice, sure, air is getting into the top. Air appears to be getting into this side of our lung. But there's a problem with this lung. If you notice that, then you are very observant and you're absolutely correct. There is something wrong with this lung. So let's zoom in a little bit closer so that you can see what's going on. What you see here is a surface tumor. In addition to that, there is a hard, massive lump that's in here. You can't see it, but you can feel it. And if you see, I'm pressing in and it's not moving. But here, on this side, I can press in and the tissue is nice and soft and spongy. But here, that doesn't work because there's a mass growing inside of there. That mass is blocking the flow of air into this side of the lung. It's a tumor. It's cancer. You can't see it, but when your lungs are not providing oxygen for your body knows something is wrong, and your doctor will know that something is wrong. Let's take a look at the tissue of the healthy lung now. So as you can tell, our healthy lung is nice and soft and squishy, good, healthy tissue. Now I know when I showed you the slice of lung, you were asking about the holes. Those large arteries and capillaries would enter into the top of your lung, and you can see how large they are because I can stick my whole pinky finger in there. And they run all through your lungs. So those blood vessels and that web work that you see there is important for carrying oxygen to the rest of your body. Just remember, your lungs are not hollow sacs of air. They are solid tissue. There are several things that can occur to a person when they're not getting enough oxygen to their brain. Memory loss, they might go in and out of consciousness, a lot of fainting, but then their body grows weaker, and so falling becomes an issue. So don't judge people who smoke, but it is important for you to understand why they're having difficulties. And if you want to live a healthier life, then don't smoke, don't vape, don't dip or chew tobacco products, and don't inhale anything that is going to cause this kind of damage to your lungs. Your lungs are important to your overall health. Besides, how are we going to fight off other things if your lungs already are sick and unhealthy? Well, we're at the end of today's lesson. I hope you enjoyed it. I hope you learned a lot. And I hope you understand our skeletal smoker friend here. This is what happens. These ugly lungs over here, it's what happens when you smoke. So don't smoke. Who needs this in their lungs? But of course, you know, this cannot just be the end. So at the end of this video, after our fun rolling credits, there are a few other videos that you can watch. You'll learn all about your immune system. You'll also learn about how your body attacks viruses and invaders into your body. And then at the very end, because I'm pretty sure you're all wondering, how does the coronavirus attack our lungs? So all those videos are at the end of this video, so please feel free to continue watching. This is your favorite 4-H agent, Jonette, saying bye-bye.
A mosquito lands on your arm, injects its chemicals into your skin, and begins to feed. You wouldn't even know it was there if not for the red lump that appears, accompanied by a telltale itch. It's a nuisance, but that bump is an important signal that you're protected by your immune system, your body's major safeguard against infection, illness, and disease. This system is a vast network of cells, tissues, and organs that coordinate your body's defenses against any threats to your health. Without it, you'd be exposed to billions of bacteria, viruses, and toxins that could make something as minor as a paper cut or a seasonal cold fatal. The immune system relies on millions of defensive white blood cells, also known as leukocytes, that originate in our bone marrow. These cells migrate into the bloodstream and the lymphatic system, a network of vessels which helps clear bodily toxins and waste. Our bodies are teeming with leukocytes. There are between 4,000 and 11,000 in every microliter of blood. As they move around, leukocytes work like security personnel, constantly screening the blood, tissues, and organs for suspicious signs. This system mainly relies on cues called antigens. These molecular traces on the surface of pathogens and other foreign substances betray the presence of invaders. As soon as the leukocytes detect them, it takes only minutes for the body's protective immune response to kick in. Threats to our bodies are hugely variable, so the immune response has to be equally adaptable. That means relying on many different types of leukocytes to tackle threats in different ways. Despite this diversity, we classify leukocytes in two main cellular groups, which coordinate a two-pronged attack. First, phagocytes trigger the immune response by sending macrophages and dendritic cells into the blood. As these circulate, they destroy any foreign cells they encounter, simply by consuming them. That allows phagocytes to identify the antigen on the invaders they just ingested and transmit this information to the second major cell group orchestrating the defense, the lymphocytes. A group of lymphocyte cells called T cells go in search of infected body cells and swiftly kill them off. Meanwhile, B cells and helper T cells use the information gathered from the unique antigens to start producing special proteins called antibodies. This is the pièce de résistance. Each antigen has a unique matching antibody that can latch onto it like a lock and key and destroy the invading cells. B cells can produce millions of these, which then cycle through the body and attack the invaders until the worst of the threat is neutralized. While all of this is going on, familiar symptoms like high temperatures and swelling are actually processes designed to aid the immune response. A warmer body makes it harder for bacteria and viruses to reproduce and spread because they're temperature sensitive. And when body cells are damaged, they release chemicals that make fluid leak into the surrounding tissues, causing swelling. That also attracts phagocytes, which consume the invaders and the damaged cells. Usually, an immune response will eradicate a threat within a few days. It won't always stop you from getting ill, but that's not its purpose. Its actual job is to stop a threat from escalating to dangerous levels inside your body. And through constant surveillance over time, the immune system provides another benefit. It helps us develop long-term immunity. When B and T cells identify antigens, they can use that information to recognize invaders in the future. So when a threat revisits, the cells can swiftly deploy the right antibodies to tackle it before it affects any more cells. That's how you can develop immunity to certain diseases, like chickenpox. It doesn't always work so well. Some people have autoimmune diseases, which trick the immune system into attacking the body's own perfectly healthy cells. No one knows exactly what causes them, but these disorders sabotage the immune system to varying degrees and underlie problems like arthritis, type 1 diabetes, and multiple sclerosis. For most individuals, however, a healthy immune system will successfully fight off an estimated 300 colds and innumerable other potential infections over the course of a lifetime. Without it, those threats would escalate into something far more dangerous. So the next time you catch a cold or scratch a mosquito bite, think of the immune system. We owe it our lives. TED-Ed is a nonprofit. If you value our work, please consider supporting it on patreon.com/TEDEd.
In December 2019, the Chinese authorities notified the world that a virus was spreading through their communities. In the following months, it spread to other countries, with cases doubling within days. This virus is the severe acute respiratory syndrome-related coronavirus 2 that causes the disease called COVID-19 and that everyone simply calls coronavirus. What actually happens when it infects a human, and what should we all do? A virus is really just a hull around genetic material and a few proteins, arguably not even a living thing. It can only make more of itself by entering a living cell. Corona may spread via surfaces, but it's still uncertain how long it can survive on them. Its main way of spreading seems to be droplet infection, when people cough, or if you touch someone who's ill and then your face, say rubbing your eyes or nose. The virus starts its journey here and then hitches a ride as a stowaway deeper into the body. Its destinations are the intestines, the spleen, or the lungs, where it can have the most dramatic effect. Even just a few coronaviruses can cause quite a dramatic situation. The lungs are lined with billions of epithelial cells. These are the border cells of your body, lining your organs and mucosa, waiting to be infected. Corona connects to a specific receptor on its victim's membranes to inject its genetic material. The cell, ignorant of what's happening, executes the new instructions, which are pretty simple: copy and reassemble. It fills up with more and more copies of the original virus until it reaches a critical point and receives one final order: self-destruct. The cell sort of melts away, releasing new corona particles, ready to attack more cells. The number of infected cells grows exponentially. After about 10 days, millions of body cells are infected and billions of viruses swarm the lungs. The virus has not caused too much damage yet, but corona is now going to release a real beast on you, your own immune system. The immune system, while there to protect you, can actually be pretty dangerous to yourself and needs tight regulation. And as immune cells pour into the lungs to fight the virus, corona infects some of them and creates confusion. Cells have neither ears nor eyes. They communicate mostly via tiny information proteins called cytokines. Nearly every important immune reaction is controlled by them. Corona causes infected immune cells to overreact and yell bloody murder. In a sense, it puts the immune system into a fighting frenzy and sends way more soldiers than it should, wasting its resources and causing damage. Two kinds of cells in particular wreak havoc. First, neutrophils, which are great at killing stuff, including ourselves. As they arrive in their thousands, they start pumping out enzymes that destroy as many friends as enemies. The other important type of cells that go into a frenzy are killer T cells, which usually order infected cells to commit controlled suicide. Confused as they are, they start ordering healthy cells to kill themselves too. The more and more immune cells arrive, the more damage they do, and the more healthy lung tissue they kill. This might get so bad that it can cause permanent, irreversible damage that leads to lifelong disabilities. In most cases, the immune system slowly regains control. It kills the infected cells, intercepts the viruses trying to infect new ones, and cleans up the battlefield. Recovery begins. The majority of people infected by corona will get through it with relatively mild symptoms. But many cases become severe or even critical. We don't know the percentage because not all cases have been identified, but it's safe to say that there is a lot more than with the flu. In more severe cases, millions of epithelial cells have died, and with them, the lung's protective lining is gone. That means that the alveoli, tiny air sacs via which breathing occurs, can be infected by bacteria that aren't usually a big problem. Patients get pneumonia, respiration becomes hard or even fails, and patients need ventilators to survive. The immune system has fought at full capacity for weeks and made millions of antiviral weapons. And as thousands of bacteria rapidly multiply, it is overwhelmed. They enter the blood and overrun the body. If this happens, death is very likely. The coronavirus is often compared to the flu, but actually, it's much more dangerous. While the exact death rate is hard to pin down during an ongoing pandemic, we know for sure that it's much more contagious and spreads faster than the flu. There are two futures for a pandemic like corona: fast and slow. Which future we will see depends on how we all react to it in the early days of the outbreak. A fast pandemic will be horrible and cost many lives. A slow pandemic will not be remembered by the history books. The worst-case scenario for a fast pandemic begins with a very rapid rate of infection because there are no countermeasures in place to slow it down. Why is this so bad? In a fast pandemic, many people get sick at the same time. If the numbers get too large, healthcare systems become unable to handle it. There aren't enough resources like medical staff or equipment like ventilators left to help everybody. People will die untreated. And as more healthcare workers get sick themselves, the capacity of healthcare systems falls even further. If this becomes the case, then horrible decisions will have to be made about who gets to live and who doesn't. The number of deaths rises significantly in such a scenario. To avoid this, the world, that means all of us, needs to do what it can to turn this into a slow pandemic. A pandemic is slowed down by the right responses, especially in the early phase, so that everyone who gets sick can get treatment and there's no crunch point with overwhelmed hospitals. Since we don't have a vaccine for corona, we have to socially engineer our behavior to act like a social vaccine. This simply means two things: not getting infected and not infecting others. Although it sounds trivial, the very best thing you can do is to wash your hands. Soap is actually a powerful tool. The coronavirus is encased in what is basically a layer of fat. Soap breaks that fat apart and leaves it unable to infect you. It also makes your hands slippery, and with the mechanical motions of washing, viruses are ripped away. To do it properly, wash your hands as if you've just cut up some jalapenos and want to put in your contacts next. The next thing is social distancing, which is not a nice experience, but a nice thing to do. This means no hugging, no handshakes. If you can stay at home to protect those who need to be out for society to function, from doctors to cashiers or police officers. You depend on all of them. They all depend on you to not get sick. On a larger level, there are quarantines, which can mean different things, from travel restrictions or actual orders to stay at home. Quarantines are not great to experience and certainly not popular, but they buy us, and especially the researchers working on medication and vaccination, crucial time. So if you are put under quarantine, you should understand why and respect it. None of this is fun, but looking at the big picture, it is a really small price to pay. The question of how pandemics end depends on how they start. If they start fast with a steep slope, they end badly. If they start slow with a not-so-steep slope, they end okayish. And in this day and age, it really is in all of our hands, literally and figuratively. A huge thanks to the experts who helped us on short notice with this video, especially Our World in Data, the online publication for research and data on the world's largest problems and how to make progress solving them. Check out their site. It also includes a constantly updated page on the corona pandemic.